In last class, we have seen type 1 and type 2 errors in hypothesis testing. So far, we have covered all basic concepts which are required for hypothesis testing. Today, we will see Z-test. There are many hypothesis tests, but in this course, we will cover some commonly used hypothesis tests: Z-test, T-test, chi-square test, and F-test. All these different hypothesis tests are useful for different scenarios and different sample data. Z-test can be applicable when population variance is known and sample size large, or population distribution is normal distribution. T-test can be applicable when population variance is unknown, standard deviation or variance, and sample size is small and population distribution is normal distribution. Even if sample size large, we can use t-test. For large samples, t-test and z-test will give same results. Chi-square test will be used if sample data is categorical data. F-test commonly will be used to compare more than two means when population distribution is normal. Let's see z-test. Z-test is a statistical test to determine whether two population means are different when variance or standard deviations are known and sample size is large. One sample Z-test. One sample Z-test will be used when we have one sample and we want to compare the population mean, which is estimated from sample mean, with hypothesized population mean, to determine whether the two means are significantly different. Hypothesized mean here is, it is some kind of research standard. Two sample Z-test. In many cases, we would like to compare parameters of two different populations to check if any difference in parameter values, such as mean. The purpose of the test is to determine whether the difference between these two populations is statistically significant. Hypothesis testing with statistical significance. Hypothesis test can be done by using statistical significance and with confidence intervals also. This is most widely used method, statistical significance. There are 5 steps involved in this hypothesis testing with statistical significance. First step is to specify null and alternate hypothesis. Second step is to specify alpha level, means significance level. It is the probability of wrongly rejecting null hypothesis. Typical values are 0.05 for 95% confidence level, 0.01 for 99% confidence level. Third step is determine appropriate test based on data and probability distribution and calculate test statistic. Fourth step is determine if we need one tail or two tail Z critical value and find the Z critical value for desired confidence level, means for specified alpha. Fifth step is compare test statistic with Z critical value for desired confidence level. If this test statistic falls within the critical region, means outside of Z critical value, then we will reject the null hypothesis. We can perform this fifth step by using p-values also. Find the p-value for test statistic, compare it with the specified significance level alpha. If p-value less than alpha, then we will reject null hypothesis. Let's see one sample Z-test. One sample Z-test assumptions are: we can perform one sample Z-test when we know the standard deviation of the population and either of these two. If the sample size is large, means it is greater than 30, or the population follow the normal distribution. Let's see one example. We have seen this problem in previous class. In particular region, in reading test, the mean and standard deviation scores are 100 points and 12 points respectively. Means mean is 100 and standard deviation is 12 points. In particular school, the mean score of 55 students is 96. We want to test whether this mean score is different from the regional mean. Observe here, I changed hypothesis statement little bit from the previous problem. In previous problem, statement was their mean scores are significantly lower than the region mean. Here we changed it to different. Different means either their scores lower than the regional mean or their scores greater than the regional mean. For this problem, we can perform one sample Z test. We have one sample of size 55 and we also know the population standard deviation sigma, which is 12 in our example, and sample size n 55, which is greater than 30, so it is large sample. This is the data we have. Population standard deviation sigma equal to 12 and sample size n equal to 5 and sample mean x bar equal to 96. Population mean mu naught equal to 100 points. We have already seen hypothesis testing with statistical significance have 5 steps. The first step is we need to formulate null and alternate hypothesis. Null hypothesis is h naught mu equal to 100. 100 is the regional mean. It is hypothesized mean. We denote it with mu naught. Here, mu is the mean of entire school students. Mu is equal to mu naught hypothesized mean. Here, null hypothesis is stating that this school mean is same as region mean, mu naught. Null hypothesis will not claim any difference between two means. Alternate hypothesis H1 mu not equal to 100. Here mu is different from this mu not 100. It can be either less than mu naught or it can be greater than mu naught. Second step is choose level of significance alpha. The choice of alpha is somewhat arbitrary, although in practice common values are 0.05, 0.01 for 99 confidence level, 0.1 for 90% confidence level, and this is for 95% confidence level. Let us choose alpha 0.05. Alpha 0.05 means null hypothesis is rejected 5% of the time when it is in fact true. The third step is to determine appropriate test to use and find the test statistic. We already seen one sample Z test is appropriate for this example. We need to calculate Z statistic. Since sample size here n 55, which is large, means greater than 30, from central limit theorem, sample mean x bar will follow approximate normal distribution with mean approximately equal to true mean mu naught with standard deviation sigma by square root n. Test statistic is the standardized difference between x bar and mu naught in order to establish evidence in support of null hypothesis. This z-score tells you how far in terms of standard deviations this x bar is from the hypothesized mean mu naught. Means this z-score represents your sample mean x bar in your null distribution. Null distribution is the probability distribution of test statistic z when null hypothesis is true. Z statistic formula is x bar minus mu naught by sigma by square root n. Here x bar is 96, mu naught is 100, sigma is 12, n is 55. Substitute all these values in this Z statistic formula. 96 minus 100 by, this is the standard error, 12 by square root 55. If you calculate, the result will be minus 2.47. The sample mean score 96, which is minus 2.47 standard error units from the population mean of 100. Fourth step is check whether it is one tail or two tail test and find the respective Z critical value for specified confidence level or specified significance level alpha. From this alternate hypothesis, we can say that this is two tail test because rejection region in both sides. If you get the values lesser than 100 also will leads to rejection and values greater than 100 also will leads to rejection. To find Z critical values, use Z table. This is the Z table. Z tables commonly will be in three ways. Some tables have values filled from the left tail to up to specified Z value like this. Some tables might have values filled from both tails up to specified Z value like this. Some tables might have filled from the middle from 0 to up to specified Z value. Here, if you want 95% confidence interval, or alpha will be 0.05. Since it is two-tail test, we need to distribute alpha equally in two tails. That is alpha by 2 equal to 0.025 in left tail and 0.025 in right tail. Z critical value for this alpha level 0.025. Let's see Z tables. See this. This Z table contains cumulative probabilities less than Z, means from negative infinity to up to Z, means here we are using this kind of Z tables, means these tables will be filled from left tail to up to specified Z value. Here is the 0.025 cumulative probability. This is in this row and in this column. So Z value is minus 1.96. To find the Z critical value for this right side, since we are using Z table which are filled from minus infinity to Z value, we need to find the cumulative probability up to this point. From here to, we have alpha 0.025 in this right tail. Total area under this normal curve is 1. So you have to subtract this value 0.025 from 1. Then you will get the cumulative probability at this point, which is 1 minus 0.025, which is equal to 0.975. So we can look for this cumulative probability in the Z table to find the critical value for this right side. Let's see the Z table. Here is the cumulative probability 0.975 in this row, and in this column it is also 1.96, but here it is positive sign because this normal distribution is symmetric distributions. So you will have equal probabilities in left half and right half of the distribution. So Z critical values for 95% confidence is plus or minus 1.96. For quick reference, you can use this table. Here our alpha value is 0.05 for 95% confidence level, and our test is two-tail test. So Z critical value is 1.96. Fifth step, compare test statistic with Z critical value for desired confidence level. This test statistic will tell us how many standard deviations the sample mean, here it is 96, from the hypothesized mean in this null distribution. It is minus 2.47 standard deviations from the mean. For 95% confidence level, Z critical values are minus 1.96 and 1.96 in right side. This minus 2.47 falls in critical region. This is the critical region, right side. This is the critical region. Here critical region is the area which contain values of test statistic that leads to rejection of null hypothesis. Z statistic falls in the rejection region, means X bar is very unlikely in this null distribution. So result is significant in support to alternate hypothesis. We need to reject this null hypothesis. We can even test hypothesis by using p-values also instead of using critical values. We need to find the p-value for test statistic. Our test statistic is minus 2.47 and compare it with the alpha. If p-value less than alpha, then you can reject null hypothesis. Let's see p-value at z-score minus 2.47. Z-score is minus 2.4, and for 7 you can see this column. It is 0.0676. It is approximately equal to 0.0068. This is one-tail p-value. For two-tail p-value, multiply this one-tail p-value with 2. You will get two-tail p-value 0.0136. This p-value calculation for right tail, left tail, and for two-tail test will be different. For more details about how to calculate this p-value, see the video Introduction to Hypothesis Testing with Statistical Significance. In that video, p-values are explained in more detail. Since we want 95% confidence level, so alpha will be 0.05. P-value of 0.05 or less than 0.05 is required to reject null hypothesis. Let's see here our p-value, two-tailed p-value is 0. It is not 0.0136, which is less than 0.05, which is less than this alpha value. So you can reject null hypothesis. Means result is significant in support to the alternate hypothesis. If z statistic is far away from the mean, then p-value for that z statistic will be less. Smaller p-values will lead to rejection of the null hypothesis. Bigger p-values means if z statistic value is very close to mean value, then probability value may come to up to here, which will be in the confidence interval range of this null hypothesis. So if you have more p-value, you cannot reject null hypothesis. In this case, it is smaller than this alpha, so we will reject this null hypothesis. Means this alternate hypothesis is true. The school students have different mean test scores from the region mean score. We can test hypothesis by using confidence intervals also. Let's see, for the same problem by using confidence intervals, how can we test this hypothesis? Confidence intervals provides an alternative to test hypothesis. If confidence interval contain true mean mu naught, the null hypothesis cannot be rejected. If the constructed confidence interval from the sample mean contains the true mean mu naught, then null hypothesis cannot be rejected. Here sample mean is 96. Confidence interval can be calculated by using this formula x bar plus or minus z alpha by 2 sigma by square root n. This entire thing is the margin of error. Here z alpha by 2 is the z critical value for 94% confidence level in two-tailed test. This x bar is the sample mean and sigma is the population standard deviation, n is the sample size. Let's substitute the values within this formula. Sample mean is 96 and z critical value for 94%. Confidence level for two-tailed test is 1.96. Just now we have calculated, and sigma is 12 and sample size here is 55. And simplify this and calculate the result. The margin of error here is 3.1752. For lower bound, you have to subtract this margin of error from the sample mean 96. Here it is 92.8. For upper bound, add margin of error to this sample mean. Here it is approximately 99.2. True mean mu naught, here it is 100. Not in the confidence interval range of 92.8 to 99.2. This is the sample mean. The constructed confidence interval from 92.8 to 99.2. This is the actual population mean 100, which is not in this interval range. So there is a statistical difference. We will reject the null hypothesis. It will be rejected and alternate hypothesis will be accepted.